Okay, so in the Lchl class this week, I'm going to continue on as if we were still in class. Obviously, what you would have done your exam, you would have done an exam at the weekend, but nonetheless, what our plan was going to be for this week was to go back to paper 1 and to start to tie up a few loose ends and a few little things that we skipped at the start of the year. So the things that we're going to do today, we're going to do 3 new things. We're going to do Pascal's triangle, binomial theorem, and the trapezoidal rule. Pascal's triangle and binomial theorem are 2 ways of doing the same thing. To be honest, basically, Pascal's triangle, binomial theorem, we're going to be looking at the same types of questions, but just doing them in a different way. Neither of these things have come up on the Lchl higher level course yet. So you won't find any exam questions on either of these, but there are a couple of mock questions on each, and you will find a big section in your books on each of these. Just because they haven't come up doesn't mean that they're not important. The course is only a couple of years old, and every year there's new things coming up that haven't come up yet. So the first half of this class we're going to spend on Pascal's triangle and binomial theorem. Then what we're going to do is we're going to look at the trapezoidal rule. Now, to be honest, when we were doing integration, we should have looked at the trapezoidal rule, but we were under pressure for time in that class, so we didn't look at the trapezoidal rule during integration. However, every time the trapezoidal rule has come up, it's come up in conjunction with an integration question. So I'm going to give you a couple of exam questions to do on that as well. And I've scanned in a revision sheet. You'll see that there's a number of questions on it. At this stage in the year, what we always start doing is revising things and just little bits and pieces that might catch you out. So in the class this week, we're going to learn these 3 things, and I'm going to give you a few exam questions on the trapezoidal rule to look at. And then I've scanned in the revision sheet, and I'll talk to you about that at the end of the class. Okay, so of the 2, Pascal's triangle and binomial theorem, I think Pascal's triangle is the easier one to use. They're both used for the same thing. I want you to just look at what I've started off with here. Imagine I had x plus y to be squared. If you multiply x plus y by x plus y, you will end up with x squared plus 2xy plus y squared. If you have x plus y to be cubed, you multiply it by itself 3 times, and x plus y by x plus y by x plus y, you'll get x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, obviously, it is practical for you to multiply those out, but what if I made that a 7 or a 9 or a 10 or x plus y to the power of 12? In that case, you would be all day trying to multiply out brackets if there's 12 of them. And in that case, we would use Pascal's triangle in order to expand it and work it out. So before I show you how we can do it, let's just look at what Pascal's triangle actually is. Pascal's triangle is exactly what it says on the tin. It's a triangle. You start off with a 1, and now the first line or 2 I can't perfectly explain. The first line is just a 1, the second line there's 2 1s, the third line there's going to be 3 numbers, the fourth line there's going to be 4 numbers and 5 numbers. And in each case, at the edge of the last number in the line will always be 1, the last number will always be 1, the first number will always be 1. And the number that goes in here is whatever these 2 add up to. 1 plus 1 gives me 2. So now I'm on the third line, which has 3 numbers, and if I go to the fourth line, there's going to be a 1 at the start and a 1 at the end, and then I add these up. 1 plus 2 gives me 3, 2 plus 1 gives me 3. And you could just continue on, and obviously I have a 1 at the end here, a 1 at the end here. 1 and 3 gives me 4, 3 and 3 gives me 6, 3 and 1 gives me 4. So it's probably worth your while just working through that. What you might do is just pause the video, and I want you to just write out the next 3 lines and then compare it to me and see if you get the same thing. So I just continued it on here, and I've ended up with this line: 1, 7, 21, 35, 35, 21, 7, 1. Basically, just the 35 comes from 20 and 15 adds up to 35. This 20 came from 10 and 10 adds up to 20. That's your Pascal's triangle. Now let me show you how we can use Pascal's triangle to expand the likes of x plus y to the power of 10 or x plus y to the power of 5 or whatever. Okay, let's just start with an easy one like x plus y to the power of 3. You should be able to do this in your head. X plus y to the power of 3. If you've brackets like this, 2 terms in brackets to the power of 3, that means there's 4 terms. If you have 2 terms in brackets to the power of 2, that means there's 3 terms. If I had x plus y to the power of 5, I know that there would be 6 terms if I multiplied that out. Basically, you just add 1 and that's the number of terms. So if I asked you to expand x plus y to the power of 3, you should know that the first term will be this to the power of 3. So the first one will be x to the power of 3. The second term will be this to the power of 2. It'll be x to the power of 2. The third term will be this, the first thing in the bracket, to the power of 1. So that's x to the power of 1. While the fourth term will be x to the power of 0. So look at just what happens to x. It's x cubed, x squared, x, and then there's no x's at all. And then what happens to the second one is the opposite of that. The last term is y cubed, then y squared, then y to the power of 1, then y to the power of 0. So that's the way we always work out what the x's and y's should be. And that's where Pascal's triangle comes into play. The Pascal's triangle tells me what the coefficients, the numbers at the start of each term will have to be. In this case, if you look at the fourth line in Pascal's triangle, it's 1, 3, 3, 1. And the reason I know I'm using this line is because there's 4 numbers in this line and there's 4 terms in this line. So if you were expanding x plus y to the power of 3, you should write it as x cubed, x squared, x, no x, and then y cubed, y squared, y, and no y. And then you look at this line in your Pascal's triangle and you realize that in fact it's just 1, 3, 3, 1. They're the coefficients in front of each term. You multiply this by 3, and you leave a 1 and a 1 there. So let's just look at another one. Let's just look at how we would, in our heads, expand x plus y to the power of 4. If it's to the power of 4, that means there needs to be 5 terms. So if I was expanding this, I know that the first one will be x to the power of 4. The next term will be x to the power of 3, then x to the power of 2, then x to the power of 1, and then there'll be no x at all in the last term. Now I need to go backwards. I know that the last term here will be whatever is the second thing in the bracket to the power of 4. So I know that the last term will be y to the power of 4, this will be a y to the power of 3, this will be a y to the power of 2, y to the power of 1, and then no y's at all. So you can more or less just do that in your head. But from here, we need to figure out what the coefficients should be. So I need to continue on my Pascal's triangle. If this is to the power of 4, there's clearly 1, 2, 3, 4, 5 terms, which means I need to get to the fifth line in my Pascal's triangle. Put a 1 at the start and a 1 at the end. 1 and 3 adds up to 4, 3 and 3 adds up to 6, 3 and 1 adds up to 4. That tells me what the coefficients should be here. The first one will be a 1, the second one will be a 4, the third one will be a 6, and then 4, and then a 1. Now, because there's a plus in here, then all of these will be pluses. Because there's a plus in there, then all of them will be pluses. Now, let's just consider what would happen if this was a minus. Imagine if it was x minus y. If it's x minus y, or if it's some term minus another term, then every second term will be negative. So let's actually just compare them. If it's x plus y, then they're all just pluses. But imagine I had x minus y to the power of 4. If you had x minus y to the power of 4, well, ultimately the first term is still just going to be x to the power of 4. So the first term will be positive. But then the second term will be negative. So it would be minus 4yx cubed. If the second term is negative, that means the third term is positive. It would be plus 6y squared x squared. If that one's positive, the next one will be negative. It's minus 4y cubed x. And if that one's negative, the next one will be positive. It would be plus y to the power of 4. So that's all the theory. To be honest, that's all the theory that you need in your Pascal's triangle. Now what I'm going to do is give you a number of questions to try. Obviously your life can be made a lot harder here, but I want you to just, if you're not 100% on that, just watch this little segment again and then try the questions I'm going to give you. Okay, in order to practice Pascal's triangle, I want you to try these 4 questions. I think in an exam it's likely to force you to use Pascal's triangle or else force you to use binomial theorem. So in this case, I'm saying use Pascal's triangle to expand the following. I'm not giving you the option of multiplying it out. So I'm not giving you the option of using the binomial theorem. You have to use Pascal's triangle to do it. So in the first one, I want you to expand x plus y to the power of 6, x minus y to the power of 6, 2x plus 3y to the power of 4, and 5x minus 8y to the power of 4. Obviously, the second two, 3 and 4, are going to be significantly harder. I want you to see how are you going to deal with it. Just follow the same logic as in my examples as in these two, and see if you can work it out. So I want you to pause the video now and work through these and then watch my solutions on it. Okay, so I've worked through the first one here. We had x plus y to the power 6. If we have x plus y to the power 6, that means there's going to be 7 terms in our expansion. And that means we need to write out the first 7 lines of our Pascal's triangle, which brings us to 1, 6, 15, 20, 15, 6, 1. To work this one out, I know the first term will have to be x to the power 6, then x to the power 5, 4, 3, 2, 1, and the last term won't have an x at all. And then I go backwards. The last term is y to the power 6, 5, 4, 3, 2, 1, and then there's no y here at all. Once you've identified your x's and your y's, you just literally write out these numbers are your coefficients: 1, 6, 15, 20, 15, 6, and 1. And since there was a plus between the two terms, that means that they're all pluses. So that's all you need to do for part 1. Part 2 is basically the exact same, except instead of a plus, we had a minus. So the first term, it'll be x to the power 6, that's a plus, the next one's minus, then plus, then minus, then plus, then minus, then plus. So you follow the exact same logic, it's just when you're assigning the signs, you do it slightly differently. But let's move on now and look at the harder ones, part 3 and part 4. Okay, the third one here was significantly harder, but we just followed the exact same logic as previous ones. We have 2x plus 3y to the power of 4. If it's to the power of 4, in our expansion, we're going to have 5 terms. Which means that the fifth line in Pascal's triangle, 1, 4, 6, 4, 1, is what's going to be relevant. The first term will be the first thing in the brackets to the power of 4. So it's 2x to the power of 4, and then the next one had a 3, and 2x to the power of 2, 2x to the power of 1, and then there was none in the last one. Whereas the last term will be this term to the power of 4. So 3y to the power of 4, 3y to the power of 3, to the power of 2, to the power of 1, and then there's none of them. The only other thing we need to slot in then is the 1, 4, 6, 4, 1. So you'll notice here I put in my coefficients 1, 4, 6, 4, and 1. And since there's a plus between them, then they're all pluses. They all just put a plus between each term. And beyond that now, I just need to simplify it. 2x to the power of 4, 2 to the power of 4 is 16, and x by itself 4 times is x to the power of 4. Here I just simplified 2x to the power of 3 becomes 8x cubed. 2x by 2x is 4x squared, 3y by 3y is 9y squared. Here I just had to simplify 3y to the power of 3 becomes 27y cubed, and 3y to the power of 4 becomes 81y to the power of 4. All I did then was multiply the coefficients. This term can stay the same. 4 by 8 by 3 gives me 96x cubed y. 6 by 4 by 9 gives me 216x squared y squared. 4 by 2 by 27 gives me 216xy cubed, and then the last term just stays the same. Now, they're quite tricky ones. I think the way an exam question is likely to come up, rather than asking you to expand the whole lot, they might ask you to find the third term, or find the term that has an x squared in it. So the term that has an x squared in it in this case would be that term. But even if it's to the power of 4, there's only 5 terms altogether. I still think your life is made easier if you just find them all and then identify which term you're actually looking for. Okay, the final one I want to work on in Pascal's triangle was this one, 5x minus 8y to the power of 4. In this case, once again, it's to the power of 4, so the fifth line in Pascal's triangle, 1, 4, 6, 4, 1, is what's relevant. The first term will be the first thing here to the power of 4, then it's 5x to the power of 3, 5x to the power of 2, 5x to the power of 1, and then no 5x. Then we work backwards. The last term will be 8y to the power of 4, to the power of 3, 2, 1, and then there's none in the first term. Because there's 5 terms in total, the coefficients will be 1, 4, 6, 4, and 1. And then we have to worry about the signs. Because this is negative, the first term will be plus, then minus, then plus, then minus, then plus. And from there we just have to simplify it down. 5 to the power of 4 is 625. 5 to the power of 3 is 125. 5 squared is 25, and 8 squared is 64. 8 cubed is 512, and then I ran out of space, so I did it underneath. 8 to the power of 4 was 4096. So to get your final answer, in each term you multiply all the coefficients. The first term stays the same, but 4 by 125 by 8 gives me 4000. 6 by 25 by 64 gives me 9600. 4 by 5 by 512 gives me 10,240, and then the last term stays the exact same. It's easy to mess up your coefficients there, so just always double check. X to the power of 4 to the power of 3, 2, 1, 0. This is y to the power of 4, 3, 2, 1, 0, so it makes sense. Now, in terms of Pascal's triangle, that's all I want to look at. The next thing we're going to look at is the binomial theorem, and I think if you're comfortable using Pascal's triangle, it makes your life a lot easier when we move on to look at the binomial theorem. Okay, so what we're going to look at now is the binomial theorem. And make sure that you've went through Pascal's triangle in detail before you look at this. Because as you can see, the binomial theorem is a ridiculously intimidating looking equation here. But it's just a jazzy way of doing the exact same thing as Pascal's triangle. It's the exact same thing. On page 20 in your maths tables, you can find this theorem. And it tells you that x to the power of y to the power x plus y to the power of n, if you want to expand that, it's n choose 0, x to the power of n. Then n choose 1, x to the power of, this decreases by 1 and you introduce a y. Then it's n choose 2, the power here decreases by 2 and then it becomes y squared. And you just keep on going until you get to n choose n, y to the power of n. Now that's really hard to interpret, but I want you to just consider what we've done in Pascal's triangle as I go through this. Supposing I wanted to use the binomial theorem to expand x plus y to the power of 3. Well, obviously in this case that means instead of n I have a 3. So the first thing I would put in is I would put in 3 choose 0. And it will be x to whatever this power is. So in this case it'll just be x to the power of 3. That's my first term, that's all I needed to do. Now, because there's a plus here, once again all of my terms are going to be pluses. And this time instead of a 0 I need to introduce a 1. So this time I'm going to have 3 choose 1, and the power of x needs to decrease by 1, so it'll be 3 minus 1, which will give me 2. But I have to introduce a y. It's going to become y to whatever this power is, it's going to become y to the power of 1. And now I just need to keep going. Obviously the next thing I do is I increase the number on the bottom again, so it's going to be plus again because this is a plus. This time it's going to be 3 choose 2, and the power of x needs to be 3, it needs to be n minus this, so this number minus this, it needs to be 3 minus 2, so in this case it'll be x to the power of 1, and I need to, now y is always whatever this power is, so this time it's going to be y to the power of 2. And according to the binomial theorem, you need to keep going until you get to n choose n, which obviously in the next term I just need to increase this again, and that's what I'm getting to. I'm getting to 3 choose 3, and it's y to the power of n. So in this case, there's no x, it's just going to be y to whatever's on the bottom here. But I want you to just look at this. First of all, 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. And 3 choose 3 is 1. That is the exact same as the fourth line in Pascal's triangle. So these choosing, 3 choose, the way we're doing that, that's just Pascal's triangle. It's just the fourth line in Pascal's triangle. The first term is x cubed, then x squared, then x to the power of 1, then x to the power of 0. So it's just x cubed, x squared, x, and then there's no x. While the last term is y cubed, y squared, y, and then there's no y. So it's just y cubed, y squared, y, and then there's no y. Because there's a plus here, you put pluses in between all of them. So, this is the same. Pascal's triangle and binomial theorem are actually the same thing. However, in a leave insert question, I think it's likely that it'll say use the binomial theorem to expand whatever, or else use Pascal's triangle to expand whatever. So as we go through this one, I'm going to say use binomial theorem, which means you need to write out this line. As far as I'm concerned, you should just do it the same way as we've been doing Pascal's triangle, just x cubed, x squared, x, and then a number, y cubed, y squared, y, and then a number. Except you can't just write out your 1, 3, 3, 1. You have to write it as 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So to be honest, we're kind of doing the same thing as we did previously, but nonetheless I'm going to give you a few questions where you use the binomial theorem to expand expressions. Okay, so I'm going to give you a number of questions here where I want you to practice using the binomial theorem. The first one, I want you to use the binomial theorem to expand 2x plus 5 to the power of 5. Then 3x minus 2y to the power of 4. If there's a minus here, it's the exact same as Pascal's triangle. You just treat every second one as if it's negative. And then the third one will be x squared plus 1 over x to the power of 3. Now, this is the way I think exam questions are likely to come up. In question 2, I'm saying, what is the coefficient of x cubed in the expansion of this? In other words, I want you write out your 7 terms and you figure out which one has an x cubed in it, and then you look at the coefficient. What's the number in front of it? What's the coefficient? Question 3 is similar. Which term in the expansion of x to the power of 4 plus 2 over x cubed to the power of 7 is independent of x? In other words, when you expand this one, in one of the terms, the x's are going to cancel each other out. And you have to tell me what's that term? What do you get? What number do you get when the x's cancel each other out? So I want you to pause the video now and work through these questions and then watch my solutions on it. Okay, so here I'm working through the first question where I asked you to use the binomial theorem to expand 2x plus 5 to the power of 5. Now I didn't have enough space to do it all on one line, so I've done it on 2 lines. The first term, since this is to the power of 5, will be 5 choose 0. And it will be the first thing in the brackets to the power of 5. The next term is 5 choose 1, and it's the first thing in the brackets to the power of 4, and the second thing in the brackets to the power of 1. The next term will be 5 choose 2, and it's 2x to the power of 3 and 5 to the power of 2. The next one, 5 choose 3, the power of x decreases by 1 again, and the power of 5 increases by 1 again. 5 choose 4, 2x to the power of 1, 5 to the power of 4. And then the last one is 5 choose 5 with 5 to the power of 5. You can think of it like that, where you do it term by term, or you could just think of it as 2x to the power of 5, 4, 3, 2, 1, 0. And then 5 to the power of 5, 4, 3, 2, 1, 0. And then the only thing, you go from 5 to the power of 5 choose 0 to 5 choose 5. Ultimately then, 5 choose 0 is just 1, and 2 to the power of 5 is 32. 5 choose 1 is 5, 2 to the power of 4 is 16, and then I just have a 5. Well, 5 choose 2 is 10, and then 2 cubed is 8, and 5 squared is 25. The next one I have 5 choose 3, which is 10, 2 squared is 4, and 5 cubed is 125. And we just work our way through the whole thing. The next term was 5 by 2x by 625. And the last one, 5 choose 5 is just 1. And 5 to the power of 5 is 3125. All I have to do then is just multiply the coefficients by each other. My final answer was 32x to the power of 5, 400x to the power of 4, 2000x cubed, 5000x squared, 6250x, and 3125. So hopefully that's making sense. Let's move on now and look at the second part of this question. Okay, for the second one, I asked you to use the binomial theorem to expand 3x minus 2y to the power of 4. So here we have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. It's the first term to the power of 4, to the power of 3, to the power of 2, to the power of 1, and then there's no 3x in the last one. I want you to notice what I'm doing with the signs here. What you could do is, it's every second term is going to be negative anyway. But what I've done is I've written them all as pluses here, which I can do if I incorporate the minus into this. I've just written each term as a plus. But then I'm saying that the last term is this to the power of 4. So it's minus 2y to the power of 4, minus 2y to the power of 3, minus 2y to the power of 2, minus 2y to the power of 1, and then there's no 2y in that one. And I want you to notice that minus by itself 4 times, that's an even amount of minuses, that will become a plus. Minus by minus by minus by minus becomes a plus. So minus multiplied by itself 4 times, that becomes a plus. Whereas minus multiplied by itself 3 times, that becomes a minus. Minus multiplied by itself twice is a plus. Minus by itself once is a minus. So every second term is going to end up negative anyway. So what I've done here then, I've 2 more lines. 3 to the power of 4 is 81, well 4 choose 0 is just 1. 4 choose 1 is 4, 3 cubed is 27, and minus 2y, I've just written this as 2y, but minus by plus gives me a minus. Here I have 4 choose 2, which is 6, 3 squared is 9, minus 2y by minus 2y gives me plus 4y squared. 4 choose 3 is 4, 3 minuses in this case has made this become a minus. 3x is just 3x, and minus 2 by 2 by 2 gives me 8y cubed. And then the last term here, 4 choose 4 is just 1, 4 minuses gives me a plus, and 2 by itself 4 times becomes 16y to the power 4. All I did then to get my final answer was multiply the coefficients of each term by each other, and that's your final answer for part 2. Okay, this is the really important one. Often you'll notice if you're going through your book, or even questions that have come up in mock papers, often have an x on the bottom of a fraction. I could ask you to use the binomial theorem to expand x squared plus 1 over x to the power of 3. So in that case, it's 3 choose 0, and it'll be the first term to the power of 3, so it'll be x squared to the power of 3. Then 3 choose 1, x squared to the power of 2, and 1 over x to the power of 1. 3 choose 2, and it'll be the first term to the power of 1, and the second one to the power of 2. And the last one is 3 choose 3, and it's the last term just to the power of 3. But let's just look at what happens when we simplify this. First of all, 3 choose 1 is 1, 3 choose 0 is 1, 3 choose 1 is 3, 3 choose 2 is 3, and 3 choose 3 is 1. So they're the coefficients sorted. X squared to be cubed, you use the first rule of powers, you use the third rule of powers, x squared to be cubed, you multiply the powers by each other and you get x to the power of 6. X squared squared is x to the power of 4, and this is just 1 over x. X squared just stays as it is. 1 over x to be squared, well, that's the same as you just square the top and square the bottom. 1 squared is just 1, and x to be squared is x squared. And then 1 over x to be cubed becomes 1 over x cubed. Look at what happens in the second and the third term. In the second term, I have an x to the power of 4 on the top and an x to the power of 1 on the bottom. So we use our second rule of powers and we subtract them. 4 minus 1 leaves me with x to the power of 3. And in this term, the x squared on the top and the x squared on the bottom actually cancel each other out, and I'm just left with 3. So your final answer for part 3, you're left with these 4 terms. Okay, so let's have a look at question 2 here. This is a slightly different take on the same as what we were doing in question 1. You could be asked, what is the coefficient of x cubed in the expansion of x squared minus 1 over x to the power of 6? In a question like this, my advice to you is just treat it the exact same as the other ones. Just go through the question, write out your 7 terms. So I started working through this question as normal. 6 choose 0 is 1, x squared to the power of 6 is x to the power of 12. 6 choose 1 is 6, x squared to the power of 5 is x to the power of 10, and if you've just got 1 minus, then the actual term becomes negative. The next one, 6 choose 2 is 15, x squared to the power of 4 is x to the power of 8, and a minus 1 over x by minus 1 over x will become a plus, and it'll be just 1 over x squared. The next term is 6 choose 3, x squared to the power of 3, which is x to the power of 6, and then minus 1 over x to the power of 3, that's 3 minuses, so it becomes a minus, and it becomes 1 over x cubed. The reason I stopped here is because I can see that this is the term that's going to have an x cubed in it. I don't need to go any further here. Look at this term. This term is 6 choose 3 is minus 20. Sorry, 6 choose 3 is plus 20, but because there's 3 minuses, it's going to become negative. But it's these two that are important. I have an x to the power of 6 on the top, and 1 over x to the power of 3 on the bottom. If you have an x to the power of 6 on the top and x to the power of 3 on the bottom, when I subtract my powers, I'm going to end up with an x cubed. So it's actually the 4th term that was the one I was looking for here. If I simplify this, it just becomes minus 20. X to the power of 6 divided by x to the power of 3 is just x cubed. So the 4th term is minus 20x cubed. Now the question asked me, what is the coefficient of x cubed in the expansion? So your answer in that case, the coefficient is minus 20. The number in front of the x cubed is just minus 20. Okay, the last one we had a look at is question 3 here. It says, which term in the expansion of x to the power of 4 plus 2 over x cubed to the power of 7 is independent of x? So it's possible to just try and work out one of them, but I think you're easier to just write them all out and then identify which one is relevant. So you'd start it off with 7 choose 0, 1, 2, 3, the whole way up to 7 choose 7. So you have 8 terms in total. The first term will be whatever's the start of this bracket to the power of 7. So x to the power of 4 to the power of 7, then 6, then 5, 4, 3, 2, 1, and then there's no x to the power of 4 in the last one. Then you'll get the second term, which is 2 over x cubed to the power of 7, 6, and go the whole way down up until the point where there's none in the last one. Now, you can start expanding it out and seeing which one will the x's cancel, but it is possible to actually just look at it and figure it out. I can clearly tell that this one is going to be an x to the power 28. 4 by 7 gives me 28. I can tell that this one I'm going to have 4 by 6, which is 24, and I'm going to have an x cubed on the bottom. 24 minus 3 doesn't give me 0, so that's no good. If we went to, like, for example, this one is x to the power 4 to the power of 4. That becomes x to the power 16. And on the bottom, we're going to have x cubed to the power 3, so that'll be x to the power 9. So I'd have an x to the power 16 on the top and an x to the power 9 on the bottom. Obviously, if you're more comfortable, you could actually work each of these out. But it's possible at this stage to have a look and realise that this term is the one that I'm concerned with. The 7 choose 4. This will be x to the power of 4 to the power of 3. 4 by 3 gives me 12. Whereas if you look at the other one, on the bottom I have an x to the power of 3, which will be to the power of 4. 3 by 4 also gives me 12. So in this one, it's going to be independent of x. The x's are going to cancel each other out. So in fact, the one that I'm looking for, the only one I actually need to write out is this one. 7 choose 4 gives me 35. If you have 7 things, the number of different ways you could choose 4 of them is 35. X to the power of 4 to the power of 3 is x to the power of 12. And then this is going to become 2 to the power of 4 on the top. 2 by 2 by 2 by 2 gives me 16. And on the bottom, it's going to be x to the power of 3 to the power of 4, which is x to the power of 12. And then just look at what's going to happen here. X to the power 12 on the top and x to the power 12 on the bottom are going to cancel. So all I need to do is multiply 35 by 16. So when I multiply it out, 35 by 16, my answer is 560. The x's have cancelled, so which term in the expansion of this is independent of x? It's the term that's just 560. There's clearly no x's in that one. Now that's all that I wanted to talk to you about in terms of Pascal's triangle and binomial theorem. It's yet to come up in the leave insert, which doesn't necessarily mean it's not important. So I think it's vital that you're comfortable with expanding each of those. Okay, the only other new thing we're going to look at in this week's class is the trapezoidal rule. The trapezoidal rule can be found on page 12 in your maths tables. And it's a formula that allows us to roughly estimate the area of an obscure shape. So you'll notice that I've come up with a random shape here. We could use the trapezoidal rule to, for example, get the area of this shape. The trapezoidal rule is h over 2 times y1 plus yn plus 2 times y2, y3, y4, the whole way up to yn minus 1. So that's a weird looking formula. Basically, h is the width of each section. If I was trying to get the area of this section, you'll notice that what I've done is I've split this into 5 different sections. And the width of each section is 2. From 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. So in this case, if I was subbing into the trapezoidal rule to get roughly the area of this shape, my h or my width would be 2. So it would be 2 over 2. And then y1 refers to the first height. y1 is whatever the height of the first thing is. In this case, my first height is 20. So the y's represent the heights, while h represents the width. So just be careful with that one. y1 refers to the first height, while yn refers to the last height. So the first thing I'm going to put in my square brackets here is y1, the first height is 20, plus yn, the last height, is 20 plus 0.5. Plus 2 times, and then I'm going to put in all of the other heights. The second one, the third one, the fourth one, and the whole way up to the second last one. So in this case, all the other heights are 21, 20, 17, and 18. So it's 2 times 21 plus 20 plus 17 plus 18. And that's all I have to do. If I just plug all that into my calculator, I'll roughly estimate the area of this shape. I want you to understand where this is actually coming from. Basically what we're doing in this formula is we're roughly saying we've divided this shape into 5 different segments. And we're saying that roughly each one of these segments is a rectangle. If this was straight across and that was straight, if these were all straight across, if they were all actual rectangles, the area I'm going to get here is if I got the area of 5 rectangles. Like for example, that is a width of 2 and a height of 21, or a width of 2 and a height of 20, and so on. Obviously that's not actually accurate. It's more or less going to be right, but that's why this is an estimate, because roughly we're pretending that this is just 5 rectangles when it actually obviously isn't. So if you just plug all this into your calculator, your area, the rough estimate for the area of this obscure shape is 192.5 units to be squared. So the formula itself is quite easy to use, but I want you to just notice that when we were doing integration, we were able to accurately get the area of obscure shapes. So if the trapezoidal rule comes up, I think it's likely to come up within integration, where they ask you to first roughly estimate the area of this shape, and then if this is a curve, they could give you the actual function for this curve, and then you could perfectly get the area by using integration. So the trapezoidal rule is likely to come up in conjunction with integration. Okay, so I want you to do this one yourself. I want you to use the trapezoidal rule to estimate the area of the following shape. So I've given you the heights. Say I've given you a line in the middle, and there's an area above it and an area below it. Like for example, this one, the distance from here to here is 8, while the distance from here to here is 10. So obviously the entire height is 18. This one I've got 13 above and 11 below. This is 10 above and 9 below, 10 above and 11 below. Here obviously the height there is just a 0 because they both meet at the end. Now the other thing, I didn't want to overdo it because I know I'm writing a lot on this one. All the widths are 2. So we can assume I didn't label in all the widths, but let's assume all the widths are 2. So I want you to pause the video and I want you to find the area of that shape and then watch my solution. Okay, so let's have a look at this one now. To get the area using the trapezoidal rule, we use this formula which we can find in our maths tables. And the area is h over 2, where h represents the width of each segment. I've divided this shape into 5 different segments, each with a width of 2. So here we'll say that h over 2 is actually 2 over 2. y1 refers to the first height. In this case, the first height is just 10. Obviously the distance from there to there was labelled as 10, so my first height is 10. While yn refers to the last height. The last height is this one here. The last height is the end, and obviously they both actually meet along the horizontal line, so the last height is 0. Often that comes up, so just be aware, usually in a lot of questions, y1 and yn will actually both be 0. If they both just meet at the end, if they both just meet at the horizontal line, then there is no height. y1 and yn have no height, they're just 0. Now I need to say plus 2 and just put in all of the other heights. y2 refers to the second height. The second height is 8 and 10, which is 18. y3 refers to the third height, which is 13 and 11, so it's 24. y4 refers to the fourth height, which is 10 plus 9, which gives me 19. And then you keep on going until you get to yn minus 1, the second last height. I've only got one more height that I need to put in. 10 plus 11 is 21, and that's my second last height. All I need to do now is plug all of this into my calculator, and it will give me a rough estimate for the area of this obscure shape. So if you plug this into your calculator, your final answer for the area of this obscure shape is 174 units to be squared. Okay, I want you to try one more question here. In this question, I'm telling you that f of x is equal to x squared plus 4x minus 5. And I want you to draw the graph of f of x in the domain x is greater than or equal to minus 5 and less than or equal to 1. So I want you to draw out a table, work out each of your x values, and you write out all your coordinates. And then I want you to use the trapezoidal rule to estimate the area bounded between f of x and the x-axis. So once you've drawn this graph, you'll have all of your heights, you'll be able to work out your widths, and you'll be able to use the trapezoidal rule to estimate the area between f of x and the x-axis. And then what I want you to do is we're going to do it accurately. We're going to use integration to find the actual area bonded between f of x and the x-axis. So what I want you to do is pause the video now, and I want you to work through this entire question, and once you're finished, then watch my solutions on it. Okay, so for the first part of this question, if I want to draw the graph of f of x in the domain minus 1 to 5, you can just plug it all straight into your calculator, or you can do it the old school way and work out a table, and ultimately you get all your coordinates. All your x values should be along here and all your y values along here. Now that I've worked out my coordinates, I can just plot the graph. So to get the full marks in part 1 in a question like this, you would just then plot all your points. From my table I've deduced that these are my coordinates. You would just sketch your graph from -5 to 1. And now I can use this diagram in order to work out the area of this shape using the trapezoidal rule. If I'm going to use the trapezoidal rule, I need to divide this shape into a number of different sections. Obviously, logically, what I should do in each case is just have a width of 1. So go to this point, go up, take this point and go up, and basically just divide my shape into a number of different segments. In each case now, my width is going to be 1. Obviously the first height here is 0. The next height from -4 to this point, that's 5, because I know this is the point -4, 5. So obviously the distance from there to there is 5. This is the point -3, -8. So the distance from here to here is 8. This is the point -2, -9. So the distance from here to here is 9. This height is 8. The height from 0 to -5, that distance is just 5, and then the last one is 0. Once I have all of these, I can just sub into the trapezoidal rule. So my trapezoidal rule, I can just take down the formula from my maths tables, and h represents the width of each segment. Clearly the width of the distance from -5 to -4 is 1, the distance from here to here is 1, and in each case I'm just going across in ones. So my width is 1. y1 represents the first height, and the first height is 0. yn represents the last height, and the last height is 0. And then all the other heights, obviously this is the point -4, -5, but it's a distance, so we ignore the fact that it's negative. I'm just concerned with the distance, so I take it as +5. So all the other heights are 5, 8, 9, 8, 5. So you just plug them into your formula, and if you plug all of this into your calculator, the trapezoidal rule estimates that the area of this shape is 35 units squared. Now let's do part 3, where we actually accurately get the area of the area between the curve and the x-axis, and we'll be able to tell how much of a discrepancy there is. Okay, in part 3 I asked you to use integration to get the exact area between the curve and the x-axis. We did a full section on this when we were doing integration. If I integrate the quadratic between 1 and -5, I'm going to get the area between the curve and the x-axis. So I just need to integrate x squared plus 4x minus 5 using the limits 1 and -5. When you integrate x squared, you get x cubed over 3, 4x becomes 4x squared over 2, and -5 becomes -5x. And notice I've put this in square brackets with my limits outside. I have a 1 up here and a -5 out here. Now 4x squared over 2 divides into 4, and obviously that can just simplify down to 2. So it's easier to write that as just 2x squared. Now I just need to sub in my limits. What I did first was I subbed in my upper limit. Everywhere there was an x, I subbed in a 1, and I just wrote that out in my first square bracket. Then you put a minus between them, and then you sub in the lower limit, which is -5. So I just rewrote this line again, except I subbed in -5. When I plugged all of this into my calculator, I ended up with -36. Now remember that we're after getting the area between the curve and the x-axis. The reason that's negative is because the area I'm getting is below the x-axis. If ever you get an area below the x-axis, you're going to get a negative value. But area refers to, it's something that occupies space, so it cannot be negative. So you just ignore the minus, and your answer is that the exact area between this curve, bonded between the curve and the x-axis, is actually 36 units squared. Notice that it's quite similar to part 2, where we estimated using the trapezoidal rule that it was 35, but the exact answer is in fact 36 units squared. Okay, so what I want you to do for next week is I want you to try 2015 paper 1 question 3. That's an example of a question where the trapezoidal rule came up. Unfortunately, there are no examples of binomial theorem or Pascal's triangle, but again, don't let that fool you. It has come up a couple of times in mock questions, so it is relevant. And then at the end, what I've attached here is I've attached a worksheet, and I want you to do questions 1 to 15 in that worksheet. A lot of the questions are quite difficult. Some of them are very straightforward. Usually at this stage in the year, we just start revising things. So what I want you to do is, there's an attachment here. I want you to print out questions 1 to 15 and attempt as much of it as you possibly can. And then next week at the start of the class, I'm going to go through the solutions to those 15 questions.